Hello everyone, you are watching Beingmathematician. I think you have noticed in thumbnail that this video is about exponential function. In this video, we will discuss each type of exponential function and its graph, domain, range, characteristics, almost everything. And at last, we should discuss a special type of exponential function and its amazing characteristics. So stay with us till the end, and without any delay, let's start the video. Now let us assume that the function is fx equal to x to the power n. Now let's see the type of this exponential function. Number 1, when n is equal to 2, then it will be fx equal to x square. So let's make a table to find its graph. So this is x and this is y. So when x is 0, then y is 0. When x is 1, then y is 1. When x is minus 1, then y is 1. And x is 2, then y is 4. And x is minus 2, then y is also 4. Now let's see the graph of this function, assuming that this is our axis. Now let's plot this point 0, 0, that will be this point, and 1, 1, that is, this is 1 and this is 1, so this will be 1, 1. Now minus 1, here it is minus 1, 1, that means here 2, 4, that is 2, and let us assume that this is 4, this is 2, 4, and here it is also minus 2, 4. Now let's draw the curve. It is clear that this curve is an unbounded curve, and it gives us a parabola so this parabola is symmetrical about positive y-axis. So clearly its domain is real number and range is positive real number. union 0. 0 is included here. So range is positive real number with 0. Now let's move to the second type of exponential function. Assuming that fx equal to x to the power n when n is greater than 0, less than 1. That means n is a proper fraction. So let n is 1 by m, where m is greater than 1 for all m belongs to capital N, that is natural number. So fx equal to x to the power 1 by m. Now we should observe two cases. Case 1, when m is even natural number. Then the curve is like that. Let's make a table to get this curve. So here 0 is equal to 0, 1 is equal to 1, and 2 is 2 to the power 1 by m. So this point is 0, 0, and this point is 1, 1, and now this point is 2 and 2 to the power 1 by m. So the curve will be like this. So clearly its domain must be positive real number, since negative real number to the power 1 by even number is imaginary or complex number, that is not real. So domain must be R plus, and range is also real number, means positive real number. So now let's discuss case 2. When m is an odd natural number, now fx equal to x to the power 1 by m, where m is odd natural. So let's make this table of the function. So this is 0 is 0, 1 when x is 1, y is 1, x is minus 1, then y is minus 1, and when 2, then 2 is, y is 2 to the power m, and when minus 2, then y is minus 2 to the power 1 by m. So let's make the graph. this is for positive x and this is for negative x. So it is the curve of this function. This is 0, 0 and this is for when x is greater than 0 and this is for x is less than 0. So clearly it is an unbounded curve which is lies first and third quadrant. Only because the sign of x to the power 1 by m is same as that of x. So domain clearly real number and range is clearly real number. Now let's discuss the third type of exponential function. Let us assume that fx equal to x to the power n when n is greater than 2. Now there are two cases arise in third type. So let's see case number 1 when n is even natural. Now let's draw the graph of this function and we get it will be a parabola which is symmetrical about positive y-axis. And we have already discussed about the domain and range of this kind of parabola. So let's move to case 2. When n is an odd natural, then the curve of this function look like the curve of y equal to x to the power 1 by m when m is odd. So let's see this curve. It will be like this. So clearly domain is real number and range also real number. Now let's move to fourth type of exponential function. So assume that fx equal to x to the power n, where n is less than 0, and in the same way this type contains two cases. So let's discuss case number 1. When n is negative even number. So let's make a table of this function. When x is 1, then y also 1. When x is 2, then y is 2 to the power n. When x is minus 2, then y is 2 to the power n, since n is an even number. Now we observe that the value of y is always positive, as the value of x is positive or negative. So let's see the curve of this case. This one is for positive x, and this one is for negative x. So this one for x is greater than 0 and this one for x is less than 0, but x is never be equal to 0, so it is an unbounded curve and symmetrical about positive y-axis. So we get a clear idea of about its domain and range from this curve. So domain must be real number minus 0, since 1 by 0 to the power n is not defined. And range, can you guess this? Yes, positive real number. So Now let's see the case 2. We know the function, that is fx equal to x to the power n when n is negative odd number. That means integer. Now the table will be like this, x and y. So when x is 1, y is 1. When x is 2, y is 2 to the power n. When x is minus 2, then y must be minus 2 to the power n. When x is 3, y is 3 to the power n. When x is minus 3, y is minus 3 to the power n. So now we can get this graph from this table. Now for positive x, it will be like this, and for negative x, it will be like this. So from this curve we can say here when x increases, then y increases, y decreases, and when y increases, then x decreases. See this, x decreases here, then y increases here. But the sign of x and y are same. So we can say from this domain must be real number minus 0 and range, yes, it is also real number minus 0. Let's discuss the type number 5 of exponential function. Let us assume that fx is a to the power x. So there are so many cases arise in this type. So let's see one by one with brief analysis. So, case number 1, f(x) is equal to a to the power x when a is natural number and greater than 1. Now, let's make a table for better understanding. When x is 0, then y is 1. When x is 1, then y is a. When x is minus 1, then y is 1 by a. When x is 2, then y is a square. When x is minus 2, then y is 1 by a square. Now, let's see the graph of this function. Let us assume that this is 0, 0 and it is the axis, x-axis and y-axis, and this point is 0, 1. Now, this curve is divided in 3 parts. One part is this. When x is less than 0 and here x is 0 and in this part when x is greater than 0. So, we can easily find its domain and range from this curve. So, domain must be real number and range is positive real number. Let's discuss the case number 2. The function is same as before, that is f(x) is a to the power x. Here a is greater than 0, less than 1, that is a must be is a proper fraction. Obviously positive proper fraction. So let a is equal to 1 by m. Therefore, function form as 1 by m whole to the power x. That means 1 by m to the power x when m is greater than 1 and m is natural number. Now, let's see the table. When x is 0, then y is must be 1. When x is 1, then y is 1 by m. When x is 2, then y is 1 by m square. When x is minus 2, then y is 1 by m to the power minus 2, that means m square. When x is 3, then y is 1 by m cube. When x is minus 3, then y is m to the power 3, that means m cube. So let's see the curve of this function. Now for positive x it will be like this, and this point, can you guess this point? Yes, it is 0, 1, and for negative x it will be like this. That means the reverse characteristic of previous curve. So domain of this function is must be real number minus 0, and range is always positive real number union 0. Now it's time to discuss the amazing observations of this special type of exponential function. So let us assume that the function is fx equal to x to the power x. Now let's make a table of this function. When x is 1, then y is 1. When x is 2, then y is 4. When x is 3, then y is 27. Now let's make a graph of this function. So this point, assuming that this point is 1, 0, and this is not on the curve, so curve is starting from very near to this point and it will strictly increasing. Now let's discuss another function, which is gx is x to the power x. Now the table of this function will be when x is 1, then y is 1. When x is 2, then y is 16. When x is 3, then y is 3 to the power 27. Look at the difference of previous function. When x is 2, then y is 4. When x is 3, then y is 27. That means this curve is starting from this point and like this. Now let's discuss another function, that is hx equal to x to the power x. Now let's discuss its table. When x is 1, then y must be 1. When x is 2, then y is 2 to the power 16. When x is 3, then y is 3 to the power 9. So y is so big, and here when x is 2, then y also so big. So let's plot this point. We get this function starting from this point and it is nearer to y-axis now. So we observe that this curve should move to y-axis when exponent of this function will increase. So here fx is x to the power x, hx is x to the power x to the power x to the power x, and gx is x to the power x to the power x. So x is the exponent of x is increased gradually, and the curve should move to y-axis gradually. I think you have enjoyed this video so much. If you think this video is so informative and useful to everyone, then please let me know your experience by commenting on this video. If you will get this type of video in future, then please give a big thumbs up. So many people have so much doubt in exponential function. So I request you to share this video with everyone as much as possible. So stay safe and stay connected.